So, just before the break there, I was talking about how the square of a binomial here, the square of a binomial was just a special case of a binomial product where that happened to be a plus b and a plus b. Likewise, the next tool in our toolkit is also a special case of a binomial product. And instead of having a plus b times a plus b, this time we're going to have a plus b times a minus b. So here we've got a plus b times a minus b, and your notes has this called sum times difference, but I think more often than not you will see this referred to as the difference of two squares. And so that's the terminology I'm going to use most of the time. It's a difference of two squares. And the reason for that name is that on the right-hand side, this is what we end up with. The result ends up being the difference of two squares. So let's do our binomial expansion and see that we do in fact get a squared minus b squared. So here we go. A plus b times a minus b. So it's a binomial product, so we'll use our FOIL algorithm, and I will go first is a squared. Outside is minus ab. Inside plus ba. And last is finally plus b minus b gives me minus b squared. So there's my FOIL. Now I'm going to collect like terms, and I know that a times b is the same as b times a, so those numbers are the same. I've subtracted it, I've added it, and so they cancel each other out, and so these just disappear, and I'm left with a squared minus b squared. So there I have collected like terms. And I'm left with a squared minus b squared, and difference means subtraction of two square numbers, hence the name difference of two squares. And so once again, the idea being, you will see this often enough that eventually we hope that you will just be able to go straight from, I recognise the difference of two squares, here's the answer. If you can't, that's not a disaster, because you'll just use your FOIL algorithm and collect like terms and you'll end up with the answer anyway. Okay? But we're just hoping eventually that you will memorise this and it will become quick, is all. So, as an example, let's do some. A, 3x plus 2y, 3x minus 2y. I would recognise that as here the sum, well, I've got a plus b and an a minus b. So the answer must be a squared, in this case it's 3x, minus the b squared. In this case it's 2y. And so this comes out to be 9x squared minus 4y squared. And there is that expansion done. Likewise, 5 plus y times 5 minus y. I recognise this as a sum times difference, or a difference of two squares. So this will come out to be 5 squared minus y squared. End of story. That's all I have to do. Again, a difference of two squared. In this case, my first number is p squared. So in the answer, that's got to be p squared, all squared. My first number squared minus my second number squared. Now, according to our rules of indices, which we'll go over a little bit later on, but p squared all squared is p to the fourth minus q squared. So that would be my expansion. And lastly, D is a little bit more complicated. It says x plus 3 all squared plus x minus 2 x plus 2. Now the x plus 3 all squared, we actually come over here and we recognise that as the square of a binomial in here. So to multiply out, or to expand or to rearrange x plus 3 all squared, I'm going to use that formula over there. And it will be x squared plus 2 times 3, which will be 6x. Actually, I'll write it in. It'll be 2 times x times 3. And lastly, plus 3 squared. There, so let me just scrub that out. That's using a plus b all squared. Now this one, this is definitely the difference of 2 squares. It doesn't matter whether I have a plus b times a minus b or a minus b times a plus b. It doesn't matter which order that's in. So this will become plus x squared minus 2 squared. So let's just highlight that there. So this is there. That's the square of a binomial. Square of binomial in there. And this one, that's our difference of 2 squares. Difference of 2 squares. There. Having done those, we can now collect like terms. And so here I have x squared plus x squared will give me 2x squared. Here I have 6x. There's no other terms like that, so I'll just write that one in. Plus 6x. And then I have 9 minus 4, which will be 5. Goodness me. And so that will simplify to 2x squared plus 6x plus 5.